True. Always true. True. Always true.
Good evening, ladies and gentlemen. I guess it's not evening, technically, it's still afternoon. Alright, so, good luck. Thank you, Steve. Thank you, Steve. I saw, Jay Satov, if you're still here, is this going to be chapter-wise? So the way I've been doing this, is I just kind of been watching the video and going on kind of until, until I get tired. Usually that takes me about 2 to 3 hours. Uh, a lot of it has to do with how much of the stuff that I'm able to do is like practical. So currently, because we're on relational operators, we're like halfway through chapter 4. We ended chapter 4 yesterday after completing the compound assignment operators, and we'll probably do. I mean, I'm gonna look over them again, make sure I still understand them after the fact, so we can like and you know, just do a quick overview of what I remember and the way that it's supposed to function before we go into whatever relational operators ends up being. So yeah. Anyways, I am. I hope you guys have been doing well. I am kind of. I've been. I am. I am not as prepared for today as I think I should have been. But oh well. Anyways, so today we're doing some more C++. We got some more. We got relational operators comparing stuff. Here's hoping that my scenes are not all messed up and that I can get everything going properly. I think I still understand and remember what we did yesterday. Here's hoping my ISP will be nice. So it seems that it mostly starts trying to screw me in the afternoon and the evenings when I'm trying to play video games and chill out. Anyways, let's get into it, shall we? No point in delaying. No point in putting it off. We have work to do. We got stuff to do. I don't know how long the rest of chapter 4 will be. I'm kind of hoping that it'll be, not long necessarily, but long enough that I feel like I've done something, because I'd hate to start chapter 5 and then have that be oh man, like we only did 45 minutes and now we have to start chapter 5 with 45 minutes after 45 minutes of streaming. I don't think it'll be that, but it's just, let's see. Code scene, here we go. Oh, nothing is showing except for my notepad that really only shows because of the. Okay, so this is the short one, and then we want this one to show this. There we go. And we can make this kind of fit to that. There we go. All right, so relational operators, comparing stuff. Oh boy, this is going to be exciting. Real quick overview of what we did last time. We basically went over what these operators do. Basically, one of these is the equivalent of saying, like, this one is equal to saying value equals value minus 5. Like, that is essentially what this says, and then it's whatever this symbol is can be changed for any of these other ones. So this is value equals value times 2. This is value equals value divided by 4. Hence why we get our the values that it spat out here, right? Because we have our value is 68 that we've defined up here, and it's like a plus 5, a minus 5, times 2, divide by 4, and then the modulus 5, which is it's essentially telling us the remainder after we divide by whatever x is. So yeah, I mean, the same goes for the thing I showed before is kind of goes for all of these different ones. I've never actually had to use modulus outside of like very basic. I think it was like I think they told me about it in like 7th or 8th grade, and that was the extent of my use of modulus. So I think we'll go ahead and comment all of this out. I always forget how best to do it. Do it that way. That way we still have this and we can refer back to it if necessary. I think at the beginning on my first streams I was deleting it and just like getting rid of it, and I don't think it's going to be a problem. I don't think I'm going to have to refer back to my very first project. But I think I like to keep this stuff as examples and as examples of things to use and refer back to if necessary. But anyways, let's continue. Daniel Garquaya will tell us more about these relational operators and what exactly they're going to be used for. Let's get into it.
Operators in C++, and these are basically operators you use to compare stuff. Let's look at a piece of code here. We have two numbers. One is 45 and another is 60. They are stored in integer variables, number 1 and number 2. We can print them out and we're going to see them on the console or our terminal. And if we go down, we can really compare them. We can use the less than operator, less than or equal operator, greater than, greater or equal operator, we can check and see if two numbers are equal by using two equal signs here. Be careful about these two equal signs, because if you use one, you're not going to be comparing numbers. You're going to be taking the thing on the right and assigning that to the thing on the left. So
Okay,
if you want
that's
to
important to make
compare,
sure.
you're going to have to type two equal signs. Another operator we can use to compare stuff is exclamation mark and equal, which is going to basically test if two numbers are equal, and we're going to get the result. One thing you should notice here is that we are wrapping our comparison expression into parentheses. That's because if we don't, we're going to get a weird compiler error that I am going to show you when we get in Visual Studio Code, but we don't have enough tools to really understand this error at this moment. So what we are going to do is avoid that problem by putting parentheses around our comparison expression here. We're going to go to...
I mean, I'm kind of curious why we're going to be doing this stuff, because this feels to me like we'd ask it, or it almost feels like asking a question, like, is number 1 less than or equal to number 2, or less than number 2, and that it should spit out some sort of Boolean answer. Ayo, wow, you're learning to compare numbers. I know, right? So high speed. We're so high speed here. But I'm mostly, it feels like almost more like I'm asking a question. So I'm curious what we accomplish by telling the computer to compare these numbers. Like I assume that I mean, it says bool alpha makes it show up as true false. All right, so we see bool alpha, but like, do we actually, is it gonna tell us, like, is it gonna give us a Boolean response here and say yes, no for each of these? So like number 1 is less than number 2. So then here we do this, and then it says number 1 is less than number 2. Yes. Number 1 is less than or equal to number 2. No. Or yes, I think. Number 1 is greater than or equal to, greater than number 2, and all that good shit.
Visual Studio Code
Yes.
and actually see this in action. Here we are in our working directory. We're going to grab the code from our template here, and we're going to put that in the current project, which is Relational Operators. We're going to go in and put
all comparison
in our
operators
code,
return a
and
Boolean
we are going
value.
to open this up in Visual Studio Code. We're going to get rid of things we don't need here.
So it is asking a question.
Our code so that we can explore.
There. Okay, so you can save them in a bool variable. Okay, that makes sense. Let's make our stuff equal to his. So int number 1, 45. The door is closed on purpose because you and your brother can't stop being assholes to each other. That's why. Don't meow at the door for no reason. I'm not gonna open it when all you do is fight each other. You silly gooses. 60. We have std cout number 1, and then this one is number 1. Oh wait, no space. What am I doing? Std end line, and then this we do the same thing, but for number 2. Play Where Is the Love by Black Eyed Peas so they stop fighting. Where is the love? I haven't heard that song in so frickin' long, dude. That's like an insane, that's like a blast from the past. Oh, I don't know why there's 2 here. Don't need those. I have a line break, and then, well, he has one that says, comparing variables. I'm going to have these, have the line break be its own thing. And then we have std std bool alpha. Make bool show up as true or false. Yeah, that's good. That's what the purpose of that one was. And then we have std cout number one. Nope, number 1 less than number 2. And I imagine we're going to be doing these for all of the different comparators. So this is our actual thing. Okay. So this is the first one, or this is our first operation that's supposed to actually spit out something that tells us something useful. I mean, these are just telling us the numbers, setting everything up. What is this? Generate doxygen comment. I don't know what that is. I don't know what doxygen is. Let's see. Clear. So then if we run this, oh, I haven't fixed it. I haven't run the task yet. Like a silly Billy. Yeah, so comparing variables. Number 1 is less than number 2. True. That is correct. That is correct. I'm a little bit confused, I guess. Or not confused. But, like, we didn't have to create, like, a bool variable or anything. Right? So, what does this just do it automatically? I mean, you said that all comparisons bring up spit out bool variable or bool values, right? So, I mean, I guess it makes sense that it would just do it if that's the way that it works, because that's the only way that it could work. Don't worry about doxygen. Okay. It's the only way that it could work. But it is kind of, I mean, it's... What do we do? Oh, gosh. I'm like confusing myself because I feel like I should have to do something with bool, but I don't. I'm not sure. I don't know why I feel that way. It just kind of, ugh. I don't know. You can also print sum by doing num plus 1, num plus 2 in the cout. But yeah, by putting it in this, I would, or I guess I wouldn't even need the no, you'd probably need the parentheses, right? What happens if you don't have the parentheses? Because like if you put it in the parentheses, then it makes sense, and it would create. I think here it would just spit out 105. Probably not. Let's see. Let's continue.
We have 2 variables. In one we have a 45, in another we have a 60, and these are integers. The name for these variables are number 1 and number 2. We're going to print them out, and we're going to see them on the console. Now we are going to compare them.
But I put them in anyway. I mean, that sounds like good practice to me.
That these comparison operators evaluate to booleans. In other words, they are going to return true or false. If you look down here, we want to know if number 1 is less than number 2. And the result of that is whether that's true or false. And this really makes sense. So because of that, we are using std bool alpha here to force stdc out to print this boolean value here.
We got a
as
little bit
true
ahead of
or
him,
false
and I
instead
started
of a
asking
1 or
questions that he was
0,
probably going to
and we
answer.
have seen this before. So if we try to build this and run this, let's bring up a terminal we can use, and we're going to run the task to build with GCC. If we go down here and run our rooster program, we're going to get our two numbers, 45 and 6. And we want to know if number 1 is less than number 2. And that's true. 45 is less than 60. So the result of this expression is going to be true. Now you know how to use this operator.
Okay.
One thing I want you to see is what could happen if you didn't use these parentheses around this expression here. Let's try this out. We're going to remove this parenthesis, and we're going to try and build. We're going to run the task to build with GCC.
He said it would give a compiler
and
error,
we're going
right?
to get a really weird error because the compiler is going to try and evaluate this operator first. If we go back to...
Okay, hold on. We're gonna run task. I want to read what the error actually says. So, error, invalid operands of types int and unresolved overloaded function type to binary operator. So it's, looks like it's talking about this. It's interesting. It doesn't seem to have an issue with number 1 to number 2, but then this part causes the issue. At least that's what the highlighting in red looks like to me. And I guess it has to do with the operator precedence that he's about to go over.
To our C++ operator precedence table and look at the operators we are trying to use in the stdcout statement, we're going to see that the operator to print things on the console has high precedence than our comparison operators here. So the precedence for our operator to print things to std out is 11, so it is higher. And the precedence for our comparison operators is 9 and 8. So the compiler is going to try and do this operator first. If we come back in Visual Studio Code, the compiler is going to try and think that you are printing number 1, but then again it's going to see this less than sign, and things are going to blow up. We don't really have enough tools to understand what is going on right now, but I just want you to see this error and show you a way to go around it and move on with your life by comparing stuff in your C++ programs.
I'm curious whether this also applies for like addition. So let's try it real quick. Run task. Build finished successfully. And if I do... Okay, so for adding numbers, and presumably, I guess we'd have to look at the table again, but at least for adding numbers, and I'd imagine multiplying and subtracting and dividing, you don't actually need the parentheses. But for comparisons, for comparisons, you do need it. Presumably because it is lower on the priority list than these things. Sag, I'm dumb. Well, I mean, you were... I think you were right on this thing, right? Wasn't it? Didn't you say that was the yeah. I mean, for number 1, number 2, you like for adding, and I would assume we'll do multiply as well. Let's test it with multiply. See if that works. Yeah, it looks like it ran, so yeah. So it works when it's just not a comparator. I keep calling them comparators instead of comparison operators or whatever the hell. Relational operators. I mean, I still think practice-wise it might be best to use the parentheses. I'm not going to be super anal about it, I don't think, but I do think that this is probably better to do than not. It is kind of, I do think it's kind of interesting though.
If you put parentheses around here, the problem is going to go away. Let's try and build again. We're going to build with GCC, and everything is going to go back to normal, and we're going to see our output if we run our rooster program here. This is how you can do this. Okay, now that we have a basic understanding of this, we can try the other operators, and it is going to be a walk in the park. We are going to go down here and put in our remaining operators. We can use less or equal operator to test and see if number 1 is less or equal to number 2. We can use the greater than operator to test and see if number 1 is greater than number 2. We can use the greater or equal operator. We can use the equal operator to test that number 1 is equal to number 2. And we can use this operator here, which is made up of the exclamation mark and an equal sign, to test and see if two numbers are not equal. And all these operators are going to evaluate to a Boolean, basically saying if what you are testing for is true or false. And we can print this out. And notice that we have these parentheses around to avoid the problem I just showed you a few minutes earlier. And if we run this, we're going to see the results. Let's build this with GCC as usual. We're going to run our program, and you're going to see that number 1 is less than number 2. This is true. Number 1 less or equal to number 2. This is also true. Number 1 greater than number 2. 45 is not greater than 60, so this is false. It's not greater than equal, so this is also false. Number 1 equals to number 2. This is going to be false. And the last statement that is going to test and see if number 1 is not equal to number 2 is going to evaluate to true, because number 1 is not equal to number 2. If this
Yeah, okay. This makes sense. We'll never forget if you always use them. You got this. True. That is true. If you always use the parentheses when you're trying to immediately print something like this, it'd be it just works. You don't have to worry about like, oh man, it's not working. I don't know why. This part just kind of, it just works. Cue Todd Howard. I mean, all of this kind of makes sense. You have the true, the false, false, because it's, I mean, number 1 is greater than number 2, and it's like, it's not like, I think it's kind of interesting, or not interesting, I guess. If the numbers are equal, then this would evaluate to false, this would evaluate to false, and these would both be true. Then I think this would be true, and then this one would be false.
this is not making sense yet,
I love
please
mathematics.
go through it a couple of times. And if you have a problem, please do ask me. I will do the best I can to help you out. Another thing I want you to see before I let you go is that you can store the result of these operators into a variable and use that later in your program. For example, here we can take our expression to compare number 1 and number 2. The result of that is going to be stored in this bool variable, and we can print it out later like this. If we run this, we're going to...
Hold on. Let's add this. So I'll do... take another line break. Come here. And then it's bool result equals number 1 equal number 2. And then we do our std cout number 1 equal number 2. Keep putting spaces in where I don't need them. And then we store our result, or we print our result, not store. We've stored the result already. So then this should just take our previous result. So this would be false, right? Because this is asking if these two numbers are the same, and they are not. And we saw it print here as false. And then result being a bool variable, because we have bool alpha up here, should still print true, even though, or not even though, like, because it should just still print true. But without this result would still print to a 1.
To build with GCC, and we're going to run the program. We're going to see that 45 equals to 60 is false, and it is coming from this statement here. You can try and change these numbers. For example, change this to a 20 and see the results that we get, and you can try and run these in your mind and see that they really make sense. If we run Rooster now, we're going to get different results because we are now comparing 45 and 20, and here at the last statement you see that they are not equal. If we put in two equal numbers, we're going to get a true there. Let's try this out. We're going to run the task to build with GCC, and if we clear so that we get rid of all this noise and run Rooster, we're going to get 20 is equal to 20, and this is true. This is really all we set out to do in this lecture. I hope you have a better idea of these relational operators in C++. We're going to stop here in this lecture. In the next lecture, we're going to learn about logical operators in C++. Go ahead and finish up here and meet me there.
All right, so let's take a quick look at the 3 different versions. So version 1 had number 2 greater than number 1. So yeah, this evaluates to true, blah, blah, blah. We used all of these. This is our first one, where number 2 is 60. The second one we made number 2 20. So then number 1 is less than number 2, was now turned to false. This one was false. This one is true. This one is true. So it's like the reverse of the other one. Yeah, pretty much the reverse. So it's true, true, false, 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 true. And then it's false, false, true, true, false, true. And then this one where we set them to equal, number 1 is not less than number 2. So that one's false. It's also not greater than number 2, so it's also false. Number 1 is less than or equal to. It is equal to, so this is true. This is true. It's not great. It's greater than or equal to. It is equal to, so that's still true. It is like totally equal to. And then this one, it's not so this one is a not equal, essentially. It's like, is this number 1 is not equal to number 2, and then this one evaluates to false. So 20 is equal to 20. Our bitwise operators in this chapter, let's see. So we just finished relational operators. We got to logical operators. There's output formatting, numeric limits, math functions, weird integral types, and then a summary. Unless bitwise operators are something like a subsection of one of those, I don't think so. I do think it's interesting that we're going to be going to numeric limits, though, because if I'm not mistaken, like numeric, when I think numeric limit, I'm thinking of like as the limit of x as something approaches infinity, type shit. But I don't know if that's necessarily going to be the case. All right, so these were compound assignment operators. This is relational operators. And we'll do boom, boom, get those like so. And let's go and continue our logical operators. This next one is going to be logical operators.
In this lecture, we're going to learn about logical operators. These operators will work on
And,
Boolean
or,
operands.
and not.
We're going to
So
look
we
at
saw
and
not
first
before.
to really make sense of how they work.
I just
Here
straight up
is a
pointed at
simple
my
table
fucking
we can
screen. You guys
use to
couldn't see
try
it.
out the AND operation. It is going to be working on two operands, A and B. And in the third column here, we're going to have the result. So if A is
I know
false
Python
and
can
B
set
is
inf and
false,
negative inf.
and
I
we
don't know
do
about C++.
A and B, the result is going to be false. If A is false and B is true, the result is going to be false. If A is true and B is false, the result is going to be false. If A is true and B is true, the result is going to be true.
So the way this, what this screams, or not screams, what this says to me is that if any element of this is false, then A and B is false. And they both so they both have to be true in order for A and B to be true.
The way you can think about this AND operator is that if any of the operands is false, the result is going to be false.
Wow, look at that. It's almost like I'm a brainiac or something.
It is going to be really easy. In the first line here, we have a false, so the result is going to be false. In the second line, we have a false, it's going to be false. In the third line, we have a false, the result is going to be false. But in the line number 4 here, we don't have a false. A is true and B is true, so the result is going to be true. Another operator
I love the way he butchers result. Look, man.
And it is going to evaluate to true if any of the operands is true. Let's look at the first line here. A is false and B is false, so we don't have a true. The result is going to be false. On the second line, we have a true. The result is going to be true. On the third line,
also not is not equals. Yeah, I realize that not is not equals. Like, this is not equal to this, right? Like, this statement is, well, I guess it would technically be this, right? This is how this is. Oh my god. Yeah. Like we've seen, but what I meant is basically that we've seen the exclamation point equal mean not in the not equal statement. Oh my god.
and we have a true, the result is going to be true. On line number 4, we have a true, the result is going to be true. And you don't really have to memorize these tables. If you use these operators long enough, these things are going to be drilled in your memory. If you have any problem with these,
I don't think I've seen these operators since I did, was it statistics? So, or is kind of like the opposite of and. So, is this another one? So, okay, I'm sure he'll tell me here in a few minutes, or a few seconds even. These also evaluate to Booleans, right? So, A or B, and then it returns either. That's what the true-false thing is, right? They're all of these are Booleans. And, like, because or is... It's not actually an opposite, but, like, just... I'm calling it that because there's 3 trues here and 3 falses on the other. Yes? Okay.
Operators, just look up tables like this and you can find whatever it is you need without really memorizing these things. Another operator is the not operator, which is going to negate whatever you gave it. So if A is true and we negate that, we're going to get a false. If A is false and we negate that, we're going to get a true. And we use this exclamation mark.
It's almost like a negative on a number.
We are negating something. If you go back to or, it is denoted by these 2 vertical bars, and the AND operator is denoted by these 2 ampersand symbols here. Okay, now that we know about these logical tables for these logical operators, we can actually try to use them in code. Here we have 3 Boolean variables. We have A, B, C. A is true, B is false, C is true. We can print them out, and you see that we are setting up stdc out to give us the results in the format of true and false instead of ones and zeros. And down here, you see that we are trying to use the AND logical operator.
Logical operators
Down
are
here
only
you have
used on
A
booleans.
and
Okay.
B, A and C, and we are doing this on 3 operators and chaining these things up. So we are saying A and B and C. And let's try and do this in our mind to see that we really understand this. We have seen that the AND operator evaluates to true when all operands are true. Another way to say this is the AND operator evaluates to false if any of the operands is false. So we're going to AND A and B. A is true, B is false, so the result is going to be false because we have a false in here. A and C is going to evaluate to true because A and C are true. A and B and C is going to evaluate to false because we have a false in here. Even if you have 1,000 trues and you end that with one false, that's going to be dragged down to evaluate to false.
Right.
That's what we are seeing here. We can also do OR operations on these things. And
oh God,
this is going to give you a true.
Oh wait,
if
no.
Any
Or
of the
operations.
operands
I thought he said order of
true.
operations.
We know that A
Whoops.
is true and B is false, so this is going to evaluate to true. A and C is also going to evaluate to true because
Oh, whenever I say A and B or A and B and C, I really mean the OR operator. Okay. So, I mean, I guess it's more important that we look at what the actual code is saying than...
A is true. A and B and C is going to evaluate
yeah.
to true
A or B or
because
C.
A is true. So let's go back and see this. These are the values we're going to be using here. We can also try out the NOT operator, and it is going to negate whatever we gave it. So if A is true, we're going to get a false. B is false, we're going to get a true. C is true, we're going to get
another false.
Another thing you can do is combine these logical operators, so we can...
Oh, fuck me, dude. How the hell? Okay, so I think he had A is true, A and B is... So B is false, so A and B evaluates to false. So I guess it would be false and false or C would evaluate to C was true, so false or true would evaluate to true, I think. I think that's what this evaluates to.
Something like A and B and OR that with a C, and you should notice that we
and then
wrapping our...
There's a not there too, so actually, okay, so false, or so it's true and false, evaluates to false, we negate that, that becomes true, true and true or true becomes true, right?
Expressions here in parentheses so that we don't have the same problem we experienced and explained in the last lecture. And one thing you should know is that for the compiler to evaluate these things, we are going to follow the rules in our table for precedence and associativity. But we used parentheses to really make this easy to follow. So we are going to AND A and B, and the result of that is going to be ORed with C. And you can try and do this in your mind, and you're going to figure this out. But we're also going to go to Visual Studio Code in a minute, and we're going to see all these things in action. The last thing you can do is combine...
Oh God, what the fuck? What is that? What is this, dude? Holy shit.
...combine logical and relational operators into expressions. For example, here we have D, E, and F. They are integers. And we can print them out like we are doing here. But we can do something like D greater than E, and we're going to AND the result of that with D greater than F. And we know that these relational operators evaluate to Booleans. So we can use these Booleans with logical operators like we have been doing all along in this lecture. So for example, let's evaluate the first one here in mind so that you really see what this is all about. D is 45, E is 20, so D greater than E is going to evaluate to true.
Okay.
D greater than F, that's also going to evaluate to true. So true and true, that's
true.
going to evaluate to true, and
Okay.
this should print a true on the terminal. We are going to go to Visual Studio Code and actually play with these things. Okay, here we are in our workbench directory. We're going to jump into our template project and copy the files we need. And we're going to put them in our lecture on logical operators. We're going to put that in here.
I'm excited to test this and see how much of this I'll understand.
And it is going to show up here in Visual Studio Code. We're going to get rid of what we don't need. And we are going to put in the code to play with these
Oh,
things.
Jesus, dude. You can't just copy in like 12 lines of code like that. That's fucked up. All right. Time to copy. Okay. True. Bool B. And then this is false. And then bool C is true again. It's pretty easy to understand. It's easy to understand, but I'm always kind of scared that I'm going to misunderstand something, and something that should be relatively simple, I end up fucking up. Because it's happened before, and I remember it happening when I was younger, with certain, I think the example that jumps to my mind is something to do with chemistry. I think it had to do with Avogadro's number. And I remember I thought I had an understanding of it, and I had what I had was a misunderstanding, and it ended up costing me a lot of points on some of my tests when I was younger. So I was a little annoyed by that. Part of the reason I didn't actually enjoy chemistry that much, unfortunately, even though my grandpa is a chemistry professor, or used to be a chemistry professor, I should say. So, all that.
We have three Boolean variables. A is true, B is false, C is true, and we can print them out. And we're going to see their values, and you see the setup here, so that stdcout is going to show things in the format of true and false. And down here, we are ending a few values. We are using the AND operator, and it is denoted by these two ampersand signs. So A is true and B is false and C is true. A and B.
Okay, let's get our stdcout basic and operations. I don't know if I actually need this. I don't think I did that one on the last thing. Cout A and B. Like so. A and B. And then we do the actual operation. A and B. STD and line. And then we have two more. So we'll do A and C. So, but then this one has an extra thing, A and B and C. And C. Itsy bitsy spider. Okay, so these are our basic AND operations.
B is going to evaluate to false because we have a false in here. And again, if this doesn't make sense, please do consult the tables for all these logical operators, and all these things are going to make sense. This is going to evaluate to false because we have a false in here. And A and C, we have true and true, so this is going to evaluate to true. And A and B and C, this is going to evaluate to false because we have a false in here.
Yep.
Remember, as soon as you have a false in your AND logical operation, you're going to get a false in your result. So we're going to have a false here. We can try and compile this and see if this is actually what we expect. We're going to bring up a terminal we're going to use here, and we're going to run the test to build with GCC. And if we run our rooster program, we're going to see that A and B is false. This is what we expect. A and C is true. This is what we expect. A and B and C
all of this is working.
false, and this is what we expect. This is how you can really play with your AND logical operator. If you want, you can change things up to really try and see if they live up to your expectations. Now we have changed A to false. Let's try and build again. We build with GCC, and we're going to run our program, and we're going to get A and B is false because they are all false. A and B are false, so false and false evaluates to false. A and C is false because A is false, so
so now everything is false because every single one has A in it.
A and B and C is also going to evaluate to false. Okay, we have these things in here. Let's bring this back to what it was before. So A is going to be true, B is going to be false, C is going to be true, and we're going to try and play with the OR operator. We are going to go down and put in.
Okay. Now we're doing ORs.
Code to actually play with this. And it is really nothing special. We are just using the OR operator here, which is denoted by these two vertical symbols. And OR is going to evaluate to true when at least one of the operands is true. Okay, so...
Right, so we understand that much, I think. So what we can do, we'll copy one of these. Just do like so. Then we're going to go change all of this, and if I understand correctly, that should be the correct operand. This should be correct. But if I mouse over it, it doesn't give me anything. I guess that's not a huge deal. So A is true, so this one should evaluate to true. So then if we do, he's got what? Yeah, we should probably do like that. Basic OR operations. We have this whole thing, and say, and I think he does the same thing as the other one, where it's A, B, and then C. So all of these should evaluate to true, because all of them have something that's true in them.
We have our values here. A is true, B is false, C is true. A or B is going to evaluate to true because A is true. A or C is going to evaluate to true because A is true. A or B or C is going to evaluate to true because one of these things is true and A is true here. We can try and run this. We're going to build this first with GCC, and if we run this, we're going to go down here and run rooster again. And you're going to see that all these things are true here because one of these things is true. And as long as you have one true operand, your OR operation is going to evaluate to true. And again, this is following the precedence and associativity rules we have. If we go back to our table in our browser, we're going to try and look at logical OR.
Wow, that's pretty low on the priority list.
Associative, so we're going to try and evaluate this from left to right. So we're going to OR A and B, and the result of this is going to be ORed with C. We have also seen
that's actually not something that I considered before. So I was just kind of doing, like, I just kind of looked at the whole thing and was like, oh, one of these is false, so the whole thing is false. One of these is true, so the whole thing is true. I didn't realize that it was actually doing it from left to right. Because, I mean, I guess that makes sense to do, right? So we have A or B. A is true, so this evaluates to true, and then it does true or C. And, I mean, both are true, so then it evaluates to true. That's actually an important thing to keep note of, because that means he showed another example a little bit ago on like during the lecture where he did something kind of like this, where there's like another value and it's essentially evaluating two different functions separately from each other. We'll probably have that as well, but I the fact that hearing him actually say it like that makes perfect sense, because it's the way I think the way I did the math stuff we did yesterday, where it was like 6 plus 5 plus whatever. I think if the way that I've done this in like school would have been to evaluate this to 11 plus 10, right? I think at least that was the way I would have learned it, because it's like, okay, so we take this group of two and then this group of two and we evaluate them simultaneously on the next line, because it doesn't change the outcome any, but the computer would do it like whoops, wrong button. Like this, right? And then it would go to here before we go to our last line. So it would evaluate it like one thing at a time, going left to right. Okay. Good to keep that in mind.
Operator, which is denoted by the exclamation mark here. And what it is going to do is basically flip off or negate whatever it is you have. If you have a true in your right.
Okay, I know when he says flip off, he means like kind of like a light switch, like to going from on to off. But like, I can't help but think that the operator is giving these numbers the finger. Okay. So I'll take this. Go boom. This will evaluate to false. But this also needs to be. This whole thing needs to be changed. So it's not A. And then we have our not A. That prints to false. And then we should be able to do the same for all of these. It should just literally be reversed. So false, true, false. B, C. Understanding these concepts is integral to redstone engineering in Minecraft. You know what's funny? It's funny that you mentioned that, because I have a couple of friends. All of my friends, or not all of, I should say, two of my friends who work in tech for like serious, like, no shit. These guys work with programming and with all sorts of crazy stuff. They are not redstone engineers, but they do like a lot of modded Minecraft, and like at least one of them played like a ridiculous amount of Factorio. I know one of them plays like Satisfactory. You only have two friends noted. Shut up, lazy. I just made a. Fine. I won't include you in my friend group. How about that, lazy? How about that?
Variable, the result is going to be false. If you have in a false, the result is going to be true. And not A is going to be false because A is true. Not B is going to be true because B is false. And not C is going to be false because C is true, as we can see here. So let's run the application and see if this is what we expect. We're going to run and build with GCC, and we're going to run rooster, and we're going to see that not A is false, not B is true, and not C is false, and this is what we expect. We have also seen that we
I thought I was I thought I was one of them. Oh no, dude. If we go through all of my friends, like let's see. Bonsai Mammoth, Redbird Lazy, Tomothy, how many more are there? I know I've got at least a couple more. Oh, Existential Bot and oh, where are you? Actually, that might be the last one. That's like 8 people that I know that work in tech. Like that aren't you. like I am like surrounded by people who know how to do this kind of thing, and I am we did this already in episode 1. Shut up. It's a good bit.
can do combinations of these operators. So for
Just
example, we can
rewatch it
look
for
at
it.
the
Shut
expression
up,
we have
dude.
here. We're going to take A and B. This is going to evaluate to false because B is false. We're going to negate this, and we're going to get it true, and we're going to OR that with C, but because it's true, we know that the result of ORing this with anything is going to be true, so we expect this expression here to evaluate to true.
Okay. Let's go ahead and put all this stuff in. I think what I'm going to do is I'm actually going to comment. I kind of want to comment out all of this other stuff that we've done. I still want to keep the booleans, obviously, but I think I want to comment all of this stuff out because, I mean, it's basic operations that we've already done and we understand. And we don't really need to print out. Well, actually, maybe we should start it a little bit after. Do like this. Oops, wrong one. That way it still prints like the beginning so that we know what what each of these is supposed to start as. Yeah. We'll probably just include this later when we comment all of it out for whatever the next thing is. std and l. And then we do combining logical operators. std and l. Then we do std cout, and we're evaluating, and we're creating this thing that we're evaluating. Like so, and then we have to go and actually create the operation, so it's not, and then we have A and B, and then evaluate that with C, and then std and L. And he's saying this evaluates to true. So let me go through, let me look at this myself. So we have our true and false. So this is false. So then because this is false, I mean, honestly, I don't even, I see that this is here and this is by itself and it's an or. So we know the whole thing is true, right? But I'm pretty sure the way that it works is true and false. This, because it's and, evaluates to false, and then we have a not false, so a true or true, and it's just kind of true, right?
If we run this, we're going to see that this is going to evaluate to true, and it is what we expect. The last thing we want to see in this lecture is that we can combine these logical operators with the relational operators we have seen in the last lecture. We are going to put in a piece of code to play with.
What the fuck, dude? Ending every sentence with a slow and L makes you sound like a Gossip Girl character. Oh no, I'm a Gossip Girl character. What am I gonna do? How could you say that to me? I'm going to be so self-conscious about it now. Oh no.
This is lengthy, but you can play with this and see what this is going to evaluate to. To start you off, we are going to do the first one together. So it does test if D is greater.
Okay, hold on. We're gonna go ahead and so we've created. Oh god, he's got this giant freaking line. So we're gonna do like this. All that stuff, all that other stuff, not necessary. So int D 45, int E 20, int F 11. So then we have just a random line there. Then we do, I guess we can just do this and then relational and logic operations on integers. Like this. Then we do std cout d, and then it's just printing each of these. Like so. Except it's E and F, and E and F. And then we have another line break here. I don't know. I don't think I even need this because I'm only... Because this, that, I mean, fucking, I'll just... Here, I'll put it up here. That way I don't have to... That way I can undo all of this and print the whole thing if I want. There. Yeah. Okay. So that's the easy part. This is the part where we just print, essentially, print 45, print 20, and print 11. And, you know, D is whatever. So then we can go to all of these different things. And these are the actual really long ones. So D is greater than E. And D is greater than F. And then it does the actual operation. And D greater than F. D and L. Okay. And this is equals. This one is changed to an or. This is changed to a less than or equal to. So then or and less than or equal to should be, you know, I wonder how much of this I could have avoided if I had simply Oh, wait a second. This is the wrong way. This one's fine. This one needs to be turned. This needs to be an OR. And this needs to be... that one's fine. Oh my gosh, okay.
Greater than E. And if you look here, 45 is greater than 20. So this is going to evaluate to true. And we're going to end that with D greater than F. The result of this is going to be true. So we're going to be ending a true and a true. And the result of this is going to be a true. And again, notice that we are wrapping this in parentheses to avoid problems with the compiler being confused with what we are trying to print. This is going to get rid of the otherwise ugly problems we might have to deal with if we didn't wrap this into parentheses like this. So we expect to see a true here, and we're going to build and run.
Okay, hold on. I'm going to copy the rest of these as well. I got the first three, 1, 2, 3, and so F is greater than E. So F is greater than E, or D is less than F. I gotta make sure this is the... What if I just did, what if I just did it like this? That works, right? Gosh. And then we have to go to the fifth one down. 1, 2, 3, 4, 5. So D is greater than F. D is greater than F. And F is less than or equal to D. Do this again. How many are there? 1, 2, 3, 4, 5, 6, 7. God, there's so many. So many. I kind of want to see if I can evaluate each of these myself just to make sure, but it's so many of them. So many of them. Ugh! We got 5. Okay, might as well just do 2 more. Copy, copy. So, second from the bottom. D is greater than E, and D is less than or equal to F. So we can copy this, put that inside of the same thing here. And then this one, I want to change. So this is not A, and D is equal to E. So then again, we got to do the same thing. So
Run the task.
he's saying this first one is true. Let's double check it for ourselves. So D is greater than E. D is 45, E is 20. That is true. And D is greater than F. That is also true. So so these two are both true, so then the whole thing evaluates to true. So then D is equal to E, false. Or D is less than or equal to F, also false. So this should be false. D is less than E, false. Or D is less than, or wait, no. Or D is greater than F, true. So this one, and since it's an or, this comes out to true. F is greater than E, false. Or D is less than F, also false. Both of them are false. This is false. D is greater than F. True. And F is less than or equal to D. Both true, so this is true. D is greater than E. True. D is less than or equal to F. False. And since this is an and, it becomes false. Not A. Okay, so that one's true still. So not A becomes false, and D is equal to E. Also false, so this is false. So it should be true, false, true, false, true, false, false. True, false, true, false, true, false, false. Terminal, run task. Let's see if we've understood this properly. True, false, true, false, true, false, false. Wow. This is, I'm not gonna lie, this is mad confusing. If you don't know what the fuck these things mean, this is mad confusing. It's kind of neat to understand and be able to like, yes, these cryptic things.
To build with GCC, and we're going to run Rooster. And if we look at the first thing here, this is going to be true, and you can try and do the other ones in your mind as an exercise. And
Already
if you have
did,
a problem,
dude.
Don't hesitate to ask me. I am going to do the best I can to help you out. This is really all we set out to do in this lecture. I hope you have a better understanding of these logical operators.
I definitely do.
You don't have to really memorize them. All you have to do is consult the tables, and you're going to basically know the result of your two operands depending on the values you have inside for AND, OR, and the NOT operator. We are going to stop here in this lecture. In the next one, we're going to see how we can format our output to make it really look better. Go ahead and finish up here and meet me there. In this lecture, we're going to look
at output formatting. How much further are we? My gosh. Okay, let's we're gonna make another new thing. Actually, there's no point in doing that. I'm gonna let me close this folder. Give me just a second to make another project. Because, I mean, frankly, it's a lot of them. New project, I don't know, 10. Oh, it does put it at the end. Cool. So created a new one, file, open folder. All right, so we're good here. All right, let's continue.
Look at output formatting in C++. And this is a way we can format stuff we send to the terminal through stdcout and make them show up better. As an example, let's say we have a table here that has names and ages, and you see that they are cramped. And through output formatting, we can take this and turn this into this. And hopefully we agree that this is better. There are a set of tools we can use in C++, and those we're going to be using in this lecture are going to be coming from these two libraries, iOS and IOmanip. And there are a lot of things in these two libraries. Here is a set of cards that show a lot of them. We are going to play with a lot of these in this lecture, so you don't have to worry if some of them seem scary right now. Before we start looking at them, I want to bring to your attention that there is a piece of documentation on these things. The link is here. The website is called cppreference.com, and you can open this up and look at some of the things we're going to talk about in this lecture. Okay, the first one we're going to look at is stdendl. This is not new. We have been using it all along to print out a new line character so that our stdcout statements print things on different lines. And if we don't have this manipulator, you see here on the top we have hello and world. And if we print them out, they are going to show up on one line because we are not separating the lines with stdendl. Down below here, we have another way we can do this. We can put a \n after our text, and that's going to add a new line character just like stdendl does. Okay, stdendl and /n in here seemingly do the same thing, but they are different, but we don't have enough tools to really understand the differences right now.
Okay.
For now, just think of them as two things that do the same thing. They print out a new character that allows your text to show up on different lines, like we have hello and world here. Okay, stdendl is the first manipulator we're going to play with in this lecture. The next one we're going to look at is stdflash, and this is going to send whatever is in the output buffer to the terminal. And what the heck is an output buffer?
Yeah, what the
Let's
fuck?
look at an example. Suppose we have stdcout here and we want to print on this terminal. And the message we want to print is hello world, how are you? So what is going to happen if the stdcout statement is executed? Things are not going to be directly sent to the terminal. They are going to go into an intermediary buffer. You can think of this as some kind of storage in which data goes before it goes to the terminal. And this is what's going to happen. We print out hello. Hello is not going to go to the terminal directly. We print out world. It's not going to go to the terminal. We print out how are you. It's not going to go to the terminal. And when the buffer is full, the data is going to be sent to the terminal in one go. And this may come in handy in some situations. So if you want the data to go to the terminal directly, you're going to add an stdflash after your stdcout statement. And we are going to play with this in a minute in Visual Studio Code, and you're going to see how this works. Another manipulator we have, which is really cool, is setWidth, and it is stdsetW here. And what it does, it specifies a width for whatever text you want to print. Here we have two examples. The first one is our table that is not formatted well. And you see we just print out the data and it is going to show up like we see here on the right. We can use stdsetWidth to set the width of the text here. And for example, the last name here is going to show up in a field which is 10 characters wide. This is what we mean here. And we do the same for the first name and the age. And if we do this, data is going to show up nicely as we see here. And again, I hope we agree that what we have down below here is much
more
better
organized
than what we had here, which was not formatted with setWidth. And this is how you use this manipulator here. We can also use what we call justification to control whether our data shows up on the right or on the left in the width that is allocated to it. For example, here, the justification is std right, so the data is going to show up to the right in its respective cells. We can also use what we call internal justification, by which if we are showing a negative number, the sign is going to be left justified, so it is going to show up on the left, but the data is going to be right justified. And this may come in handy if you want to display some tabular data in your terminal. We can also use stdsetFill to specify the fill character in our empty spaces. For example, here we set the dash as our fill character, and the result is what you see down below here.
Ooh.
We have seen stdbul alpha, and its effect is to force stdcout to show Boolean output in the form of true and false. If you don't put this manipulator in, you're going to see those pieces of data as ones and zeros.
Yeah, that
so
whole
for
thing
example,
before
here
would
we
have
have
been
two
one-
variables,
would have been
condition
1, 0,
and
1,
have a
0,
condition.
1,
If
0,
we
0.
print them out, they are going to show up as 1 and 0. We are going to set our manipulator here, so the data is going to show up as true and false.
This is all
We can
helpful.
disable this manipulator here with std no bool alpha, and the data is going to go back to be shown in the form of 1 and 0. This is what this manipulator does. We also have one to show the positive sign for positive numbers. So if we don't enable it, the data here is going to show up like this, 34 and minus 45. You see that the minus sign is going to be shown regardless of the setting you have for this manipulator.
Oh.
But if we enable std show pose, we're going to show the positive number, and this may make sense for whatever application you might be doing.
Yeah.
We can
Looks
disable
like
this with
you're equipping a better
no
weapon.
show pose.
That's my first
And
thought.
after we do this, the data is going to show up in its default format that we have seen before. This is how you use std show pose. We also have manipulators to control the base in which the data is shown, and we can show the data either in decimal, in octal, or in hexadecimal. If you look at the data here, we have an integer which is positive, we have an integer which is negative, and we have a double variable here, and we have some data n for us to play with. We're going to show our positive integer in these three bases, decimal, hex, and octal. And the result is what you see here, and this should be no surprise. You already know these number systems and how they work. We can take the negative number and also show it in different bases, decimal, hexadecimal, and octal, and it is what you have on the right here in our terminal. If we go down and try to show a double or a floating point number in these bases, the result is not going to change because these number systems have no effect on floating point numbers. If you remember, we have seen that floating point numbers are represented in memory following another protocol that is really advanced for a course like this. So we are just going to use this, but we're not going to try and understand it because it is out of scope for what we are doing here. We can also use std show base to show the base of our output. So here we have a positive number, which is an integer, and we can show
so
it
on this
in
one it's
decimal, hex, and oct.
it's showing the
And
0
we're going to
at
see
the
what
beginning
we
for
see here to the right,
octal and
but
0x
we can
for
choose to also
hexadecimal.
show the base of whatever it is we output. If we want to specify that the output is in decimal, we're going to say that here.
I assume
But
if we did a
can also
binary one, it would
decide to
say
show the
0b.
base, and we enable that with std show base like this. And if we do this, we're going to see decimal is not going to have anything in front. Hex is
'cause
going to
decimal
have
is
a
just how we
0x
count,
in
so-
front. Oct is going to have a 0 in front. And by this, it is going to be very easy to see the base in which your data is displayed. We can also use std uppercase for the data we print out to be shown in uppercase where it makes sense. For example, here we are trying to print numbers in hexadecimal here in the middle. So if we don't use uppercase, which is the default, the number is going to show up like this. You see A and F are lowercase, but if we enable uppercase, we're going to see this in uppercase. And sometimes this is going to be helpful for whatever application you are using this in. We also have a few manipulators to control how floating point data is shown on the terminal. And the two of these are std scientific and std fixed. By default, std cout is going to show in scientific format where necessary, and it is going to use fixed by default. So what we have here, we have three variables, A, B, C, and if we just print them out, they are going to show up in this format here. If we use fixed, we're going to force the output to be in fixed format, and you're going to see that the third number in C here is going to show up as 0.0 and a few zeros after that. because
Because
in the
it's
precision that we have now, we can't
like
really show a
10 to
number
the
that is as
negative
low
10.
as we have here in
So you
C.
don't.
Again,
It's too
we have
small.
seen this
You can't see that
scientific
number.
format. This is basically 1.34 multiplied by 10 to the power of minus 10. And this is a really, really low number. So we're going to do 0.000 up to 10. And that's when this decimal point is going to show. So it's a number that is really close to 0. That's why we are showing it like 0.0 here. I hope this makes sense.
You'd need
You
a
can also
precision
use
of like way
scientific
more
notation
than
if we
what's
want
shown.
that. And if we force scientific notation, everything is going to be shown in scientific notation. Another thing that I really want you to be aware of is that there is no official way to set the floating point output to its default. And here is a hack I actually learned about when I was making this course. The explanation of this is really out of scope for this course, but just use this to set the floating point output format.
Dipped out for a second,
to
you're
the
back. No
default.
worries, man.
And if you do this, you're going to get whatever we had here with the defaults. You're going to see that it is the same thing. The next thing we're going to look at is std set precision, which we have seen before. And this
We did
is going
set precision
to set
before.
the precision with which the data is going to show up on the terminal. If you use a precision of 10, that's what you're going to get here. Here you see that we have a double number. It is a
Looks like that's
number
pi.
that has a lot of numbers after the decimal point. If we show it by default, it's going to show up like this. The precision is going to be set. We can increase the precision to 10, to 20, and to 50, and it is going to show up at whatever precision that you specify here. Please note that this precision is going to be limited by the type of this A variable. If it is a floating point, the precision is going to be something like 7. We have seen that. If it is a double, the precision is going to basically double to something like 15. And if you have a long double, the precision is going to be something bigger than double, but it can't go below that of a double. We have seen this before. We also have show point, which is going to force showing the decimal point for floating point values.
Not gonna lie, this is useless. It feels kind of useless. It seems kind
the
of.
most important piece of
I'm
data
not quite
we have
sure why
here.
we're learning it.
If we don't do show
It
point,
seems very.
this is going to show up as 12 in the output.
I mean, I'm sure it matters
but
to
we can
somebody,
use show point
but I feel
to
like
force
generally
for
speaking, I'm
the
not
decimal
trying to
point
show
be shown,
numbers
and
and
you
stuff
see
in the
that
terminal.
12.00
I'm
here
gonna be
is
looking
shown.
at it somewhere else.
Another side effect of this is that show point is
Like,
going
I mean,
to
we're
force
talking about
the
like
showing of
formatting the
trailing
terminal.
zeros, and it is what we see here in D.
You should
E,
probably
and F.
not use
we have
C out
seen
or
a lot of
or
manipulators.
C
Here
in
is a
code.
table that is going to show where many.
I mean,
of these are
generally,
going
I'd
to be
imagine you'd
living.
want to.
So if you need to use set width, this is going to be living.
Your inputs are going to come from
IO
somewhere that is
manipulator.
not the terminal.
And here we have
Right.
a few other ones. So if you want to use a few of these things, these are the libraries that you will need to include with #include, as we have been including IO stream. And again, the documentation for these things is shown at cppreference.com. This is the exact link, and you can check this out if it helps out. Now that we have an idea about these things, we're going to go in Visual Studio Code and actually see these in action. Okay, here we are in Visual Studio Code. The project we're going to be working on here is output formatting. So we're going to be
I'm curious why output formatting is a whole
and
thing.
put those in our project
I mean, I'm sure that it's
here.
important for somebody.
And we're going to go up again
cppreference.com.
and open up this folder in
Yes,
Visual
we're going to
Studio Code.
CPP.
Let's do that. We're going to close the welcome screen here, and we're going to remove whatever it is we don't need. We're going to take this out, and we are going to put in the first code we want to play with, and this is stdendl. You don't really need a lot of explanations for this because we've used this all along. If you don't put it out, the data is going to show up on one line, and you're going to have hello world on one line.
Have more time there than
stdendl.
I love CPP reference, great site. Have more time there than most of my Steam library.
And world
I mean,
different lines,
it's a fucking
and it is
huge
possible
repository
to
of
use
information,
the
right?
\n to achieve the same thing.
We've already
but
tested
these
this on our
work
first day,
very
this
differently
\n.
underground. And we don't have enough tools to really understand
I don't
the
know if I
difference.
need to be
So
doing
for now, just
this.
take this as the truth and know that there are differences. And the most important thing is
End
that
L
to
and slap
recognize these
backslash N
things
are
if
they're
you
different
see
in
them
some
in
way.
code out
Shortly.
there. We are going to bring up our terminal and build this with our task that is going to build with GCC. You're going to see that the build is going to go through, and we can run our rooster binary.
This
to
is
see
just
the
text
output.
again.
You see that we
Didn't
have
we do
hello
this in the
world
first day?
on one line. We have hello and world on different lines, and this is a result of these things we have here. You see, we have std and dl.
I appreciate you being thorough, Mr.
The terminal
Gakwaya,
to go
but
to the next line and print world, and after that we're going
did
to
do
force
this,
the terminal
this
to go
much.
to the next line, and that's
This
where
is literally
the next
hello
text
world.
is going to show up. After that we have hello and world down here in the terminal, and it is the output generated by the statements that we have in here. And you can see that it is going to basically do the same thing as std, endl, but again, they work very differently under the hood. Okay, so this is really how std, endl works, and you get access to it by including the IOStream library here. The next thing we're going to play with is std flush. This is going to flash the output buffer to its final destination, and that's
so
going
this
to
is
be
something different. We
the
haven't messed with
terminal in
std
this
flush
case.
before.
And if we add that to our stdcout statement like this, this is going to be directly sent to the terminal. And this may come in handy in some applications. If we run this, we're not going to really see a difference, but underground, under the hood, the data is directly sent to the terminal, and we had a chance to explain this in the slides earlier.
Oh,
We can build this
so
program
it's functionally
and see
identical.
it running. The build is going to go through. If we run rooster, we're going to see that this is a nice message is sent to the terminal. The next thing we're going to look at is set width. I am going to put in the code here because I don't want to type all this. And again, you can get the source code for this in the resource section of this lecture. You don't really have to type all these things. The most important thing is that you really understand how they work. Okay, you see here we are going to use set width, but we haven't really included the library that is going to give us access to this. And if you don't know which library you will need to include to get access to this, well, you can check the documentation. And to get access to the documentation, you might want to consult your favorite search engine. I am going to go in Google here and type in std setw, and I am going to search, and this is going to come up with a few entries. I am going to click on the one from cppreference.com because this is reliable in my opinion. And if we open this up, we're going to see that
actually this is all useful for when you'll have to make Minesweeper and terminal.
So this is what we need to
is that
put in
my
Visual
is that my
Studio
final
Code
project?
to get rid of this problem? Let's do that. I really wanted you to see this process you can go through to know what you need to include. We're going to put this in, and hopefully the error is going to go away and we can focus.
Okay, so let's mess with the unformatted table stuff. Unformatted table. And this one's... I'm not going to do everything. I'm going to do probably 3 lines. Because... Oh, that's right, yeah. I'm going to do, like, probably 3 lines of this. Just because, I don't know. I don't know how deep the tutorial goes. Maybe you don't even need to finish it all for Minesweeper. Maybe. We'll see. We'll see. I'm sure we'll figure it out one way or the other. So we have the table. So we're doing 3 names. We'll do Stanley Woods. Oh, whoops. I forgot to include the age. My copy and paste skills could use some work. All right, Stanley Woods, 33, and Jordan Parker, 45. All right. We're not going to be doing more names than this.
On studying the effects of these things here. This is going to print unformatted, so the data is going to be cramped close to each other, but we can format this using set width. And if we pass in a 10 here, we are basically saying last name is going to take the width of 10 characters, even if we don't really have 10 characters in this. So you're going to have spaces fill the remaining spaces so that the data shows up nicely. This is really
It's like
hard
manually
to say
formatting
in
your
Word,
shit
so I
in
am
Word
going to
because
run
you're
this
10
in a
and
minute
don't
so that
understand
you
how
can
it
see
works.
this. But before we run, I want you to see that you can also store the width information in a variable like this, and use that instead in your std statements. The benefit with that is that it is really easy to change this width if you happen to change your mind. Otherwise, you would have to change a lot of things.
Is it? I feel like I'd have to change all of these 10s to 9s or to 15s or whatever it is that I end up doing. I feel like set width... I mean, I guess technically I could set an integer. Like I could call it width and then set that as my... Like set width and then set it to whatever I put the integer to be. That's probably more useful. Or not more useful, but like... But like at least more malleable, I guess.
Thanks. And this is really bad design. I did this to show you how you can use this, but in real code, you are most probably going to store your width information in a variable, and that way it's going to
Holy
be
shit,
really
dude.
easy to change and update if you happen to need that. We can build this program with GC.
I'm a freaking genius, dude. Hold on. Let's do... Big brain. Dude, for real. For real. I got such a fucking huge brain. I'm out here dunking on Suds with my huge fucking brain, man. Alright, formatted. So this one is formatted table with variables, but we're just going to skip straight to that because doing set width of 10 is just kind of dumb, I think. That's working harder, not smarter. So we'll set an integer. Int. He does 14. We might as well do that. Call width 14. And then, what is it? So I'll call this formatted table. And we'll do std cout and std set width call width last name, and then it's call width again, and then I assume that it's first name. I think that's the way it's done. Sensei never fails. He's just late sometimes. I mean, so far, and I don't even know if I would say that he's late. It's just that I keep pausing the video and then like asking questions and then like, and it's like immediately answered. I don't know what I don't know. Am I just getting ahead of myself?
And if we run it, let's bring this up a little bit. We're going to have our...
Alright, then he also has another one for age. So we'll do this again. So first name. and then it's like we've created 3 columns essentially, and then it's age, and then std and l. I believe that's the way that this is going to look. So we're going to do 3 lines of it. So we're doing Gray, Woods, Parker, and Daniel Stanley Jordan. Daniel Stanley Jordan. And then it's 25, 33, 45. 25, 33, 45. Terminal, run task, clear, and that's our formatted table. I mean, I do think it looks better than the unformatted thing. This looks like it's intentional, right? Like this, we've created an actual table. This is like a list. I mean, we called it unformatted table. I do think that it's probably better to do it like this if you're going to use the terminal for some reason. I do think it's probably better to do it like this if you're dead set on using a table in the terminal. Because, I mean, it's much clearer. And also this, having to do these fucking things, creating little spaces, drives me insane. I do not like it. Yes, that's how you do it.
Data that is
Oh,
unformatted, and you see that it is really ugly. But down below here, we have our formatted table, and it is really nice. We have last
I do
name,
think that
first
3 is
name,
good
and
enough to
age,
demonstrate
and it is
the
easier to
concept,
see
though.
these things. We're going to see that it is possible to force the data to show on the left or to the right with justification, and we're going to look at code that does that next. If we go down here and put in the next piece of code we want to play with, we're going to see that data is right justified by default, but we have seen this also. You see that gray is cramped to the right of the width of the cell for the first name. So data is right justified by default. And it is the same here. If we change the width of our data here and try to run, we're going to have a better visualization of that. So let's run a little bit. We're going to build, the build is going to go through, and if we run this, we're going to see that data is going to show up to the right. Gray is to the right, Woods is to the right, and this is the default justification you get when you set width like this. You can also cause for the data to be left justified, and you do that by coming here and changing this to left. You can do that, but let's keep this in here.
Okay, let's take a look at. Let's do it like this. Let's we have our thing there, std cout std, and we'll make this left. So this should change it so that it's justified to the left, is my understanding. I did work on the CLI for 5G towers, and that's how it worked. The command line interface. Okay. I mean, that's like you had to essentially mess with this stuff, like in the terminal, like doing work in there. Libtard lefties. And look at that. Now it's justified to the right, or to the left, I should say, instead of the right. Look at that. So we have our unformatted table, our formatted table. It's driving me insane that this is the way that it is. So we can, now it's like that. And then we can change the column width. We didn't need to. We don't need to copy a whole second table that he's doing here.
Instead,
That's a lot of work
for
for
your
no
reference,
real.
and let's put in another piece of code to justify the data to the left. Okay, let's go down and do that. We're going to justify the data to the left, and if we print this out, the data here, gray, should come to the left and be aligned with the first name here. I hope this makes sense. We're going to run. We build with GCC, and if we run Rooster, gray is going to be justified to the left. This is the meaning of std left and std right that we just saw. And note that data is justified to the right by default, and it is important to keep the defaults in your mind. Data is going to be justified to the right by default. The next thing we can do is to make our data internal justified. And what this is going to do is make the sign left justified, and the data is going to be right justified. And the best way to see this is really to see an example. So here we have the data. It's a negative floating point number. The width is set to 10. It's going to be right justified, but we are also going to set the justification to internal and see the difference. Let's build and run this. We're going to build with GCC, and we are going to run our Rooster program. And if we look at the output here, you see that if we have...
Okay, so that's a different thing that he's doing. I think he's just... It's just that negative symbol that he's justifying with that. Internal justified, yeah. We can copy this too. So we'll do std cout std end line. And we'll do std cout internal justified. And then we go end the line. Then we do std cout std right, and then we'll do std cout std set width. Oh no, it's set w. Set w. He sets it to 10. I don't know if it really matters for this example. I would do negative 123.45 end line, and then this one sets it internal set width 10 negative 123.45. That one's like this. Okay, so with this one, internal, all it changes according to this is where this negative is going to show up. This one funky little character. I don't know if you guys can hear that. He's meowing at my door. Let's do this properly and end the line. Run task. So internal justification only does this. Nopers? What do you mean, nopers? Oh, you don't hear? As in you don't hear him. Okay. At least that's what I'm guessing. So with this, I feel like it's a little bit weird that internal just does this. Like, am I... Can't hear cats? Yeah. Yeah, my mic's not picking him up. He's screaming outside my room. I still think it's kind of strange that this is how it works. I kind of would have assumed that justifying this to the right would bring the negative sign over by default. Hold on, I'm gonna open my door. Sorry about that. I'm back. But yeah, so I'm kind of, I guess, not confused. I just kind of don't understand why internal needs to be its own thing. Or I guess, well, yeah, okay. No, I had a misunderstanding, or misspeaking rather. So it brings over this, but like, why would you want that instead of like, why would you want to have whatever symbol internally justified on its own? Like, if you have a table of negative numbers, surely, uh, surely you would just kind of have the negatives with the numbers. You wouldn't necessarily want the negatives all on their own. At least I don't think so. Come on. Are you going to jump up? There you go. All right. Let's continue the video.
Have a right justification, the sign is going to go with the data. Whereas if we do internal justification, the sign is going to go to the left and the data is going to go to the right. And sometimes this is useful depending on the application that you are building, especially in applications where you have to display tabular data on the console or the terminal. We can also specify the field character using set field. And this is really how it works. The data is going to be left justified, but we are going to fill empty spaces with a dash here. And we can bring this up so that you see the entire thing. But you don't really have to type this out. You can use the code I have provided in the resources section of this lecture. You can just copy it, paste it in here, and use it to play with these things. Okay, with this, our empty spaces are going to be filled with this dash character. Let's build and build with GCC. We are going to run this and you're going to see that we have our field character here, and you can change this basically to whatever you want. If I want, I can change this to a star. Let's do that. And I can build again. If I run this, it's going to be filled with stars right now. The next thing we're going to look at is STD Bull Alpha. We have seen this before, but what it's really going to do is force the output to be in the format of true and false, and the default is in the form of 1 and 0.
Because
here we have a few variables, and they are of bool type. The first set of stdc out statements here is going to print in the format of 1 and 0. We are going to set the output to bool alpha, and it is going to be in the format of true and false. And we can disable the
Yeah,
bool
so
alpha with
basically
this
what this
setting
is
here,
all this
which
part's
says
telling me is
std
how
no
to
bool
turn
alpha.
off bool
We can
alpha
quote
for
this
some reason
and
we need.
see the effect of this. So we're going to run rooster again, and you're going to see that condition 1 0, condition true false, condition 1 0. We are able to modify how our Boolean data is displayed on the console using these two settings here. Use them if they make sense for your application. The next thing we're going to look at is show pose, and we're going to just put in the data. We have two numbers, positive number, which is 34, a negative number, which is minus 45, and we can decide
then this is
if
just
we
showing
want
how
to
show the plus
sign
sign
for
and the
positive
negative
numbers.
sign.
By default,
Well,
the
by
plus
default, the negative
sign is
sign,
going to be
or
hidden.
by
It's not going
default,
to
the
be
positive
shown.
sign
If you want it shown,
is
you
not
can
shown,
use the show
and then the negative sign
pose
has to be because
manipulator.
that's
And
the only
if
way
you want to
know.
disable that,
Show
when
pose.
it was
Show
enabled,
pose.
you can use no show
Did you learn how to
pose,
make
and
serve
this is going
bots
to do
yet?
what
No.
you want.
I
We
do have
can
a friend
build
who knows
this
how to make serve
again,
bots.
and if we look at the output, we're going to see that pose num doesn't have a plus sign in front because by default the show pose is disabled, and we set the setting here, and we're going to see the plus sign.
Yeah, so
and
this
if
is
we
just turning
disable
this on.
that, we're not
Serve
going to
bots,
see the plus sign
they're
again.
from
This is the effect of
The
STD
Misadventures
show
of Tron
pose
Bond.
and STD no show pose manipulators. We can also affect
They're
the
very cute.
base in which the data is displayed on the terminal, and we do this by setting the output base system. We can set stddec to force the output in decimal, stdhex to force the output to be in hexadecimal, and stdoct to force the output in octal. And this
Never heard of
is
it. It
only
is a
to take
fairly
effect for
niche
integral
old game.
types. This is not going to have effect for floating point numbers, for example. Here we have a few variables, a positive
STD dick.
integer, a negative integer, and a
Tag
floating
me
point
in
number,
codes.
which is the double. And we're going to try and print these things in all these base systems. We're going to print these things in the default format. We're going to see how they look. We are going to take the positive number and show that in these different number systems. We're going to do the same for the negative number, and we're going to show that this doesn't have effect on floating point numbers because these number systems don't really work for floating points. We can run this and see the output. We are going to run the task that is going to build with GCC, and we're going to clear and run rooster. And what we're going to see is that by default, positive number is going to be this, negative number is going to be this,
so
and our double
this
var
is
going
interesting
be
to
this.
see, but
And
he
we are
already
going to
went
take the
over
positive
it
number, show
in the
it
lecture
different
portion of
base
this,
systems. In
and
decimal,
I'm
it's going to
not
be like this.
particularly
In hex,
interested
it's
in
going to be
printing
like this.
numbers in a bunch of
oct,
different ways.
it's going to be like this. The negative
not a
number
very
is also going to
practically,
be in this format here.
or it's
so
not
if
much
we show it in
more
decimal,
than
it's
what
going
we
to be
already
like
know.
this. Hex
It's
is going to
just
be
kind
like
of
this,
neat to
and
see,
octal
I guess.
is going to be like this. You can see that the double var, which is a floating point, is not really affected. It's going to be showing in the same format regardless of the base that we set here. One thing you should know is that this base setting here is going to stick. So here, for example, you see that we have set output to octal. So any other thing that we're going to print out is going to be shown in octal. And we have to be sure that's what we want. If that's not what we want, we will have to reset the output number system, and it's going to take effect. This is how you can use these things to affect different number systems for output in your terminal. We have seen that you can also force things to show up in uppercase if that's important for your application. For example, here we have a positive number. If we show that in hex, this is going to contain a few characters.
Print Dr.
And
Octavius.
if we don't set uppercase, it is going to show up in lowercase. And if we want it in uppercase, we can set this setting, and it is going to show up in uppercase. This may be helpful in some applications, and I just want you to be aware of
There's a lot of things that
these things.
that he shows us
We're
that
going to
might
build
be helpful in
and,
some
run
applications.
our application. We're going to see that.
I think.
Let's bring this up a little bit so that we have some breathing room. Our positive integer here is going to show up in lowercase here in hex because this is going to contain characters. And if we set uppercase, you're going to see that the characters are going to show up in uppercase. And this is the effect of this setting here. We can also affect how floating point data is printed out on the terminal. For example, here we have a few variables A, B, and C, and by default they are going to show up with decimal points and use scientific notation where necessary. But we can choose to use fixed, for example, if that's what we need in our application. And the output is going to be shown using fixed notation with
he
decimal
talked about
points.
this already.
If
This
we
is
want,
just
we can
printing
force
numbers.
the scientific format, and we do it like this. And all output is going to be in scientific format. And we can disable all these settings, and
This
we
is
set
all
this
output
to
formatting.
the default.
I wonder how much
With
is going to be in the numeric limits and math
here.
functions.
There is no official way
and the
to
weird integral
set
types.
floating point output to the default. And this is a hack I actually learned about when I was preparing the code for this course. And the proper explanations for this are really out of scope for this course. So if you want to reset the floating point output format to the default, you're going to use this, but we don't really have enough tools to understand this yet. So just take it by faith, and you're going to see that if we run this, it's going to work. Let's try and run this through the compiler, and the build is going to go through. If we run this, and bring this up a little bit so that we have a little bit of breathing room, we're going to see that our double values are A, B, and C, and that's what we have in our code here. And by default, it's not going to be able to show.
It doesn't show the whole number because
the precision limits.
Too
so we're going to
precise.
have 3.14159.
And then even where you try to change the precision limit, it has a maximum.
If we use fixed format, you're going to see that whatever we had in scientific format, it's going to show up in fixed format. And again, this is a really low number. That's why we have 0.0000 here. We can force the output to be scientific as we did right here. And all output is going to be in scientific format. Down below here, we use our hack to set to the default. And you see that it's going to go back to the initial format that we had before. This is how you use std fixed and std scientific to manipulate how your floating point numbers are printed to the terminal. We have also seen that we can set the precision of our output in the terminal.
Kind of sad he's not teaching you things from the C Studio library. C++ is backwards compatible mostly.
Here, if you hover over a variable, you're going to be able to see its type.
I mean, from what I understand, C++ at the very least started as an extension of C, so that makes sense.
But we can choose to set the precision to 10,
I don't know
20, or
exactly.
whatever it is really
because I know that I think C.
Please note that this is going to be limited
C started
by the
in like
precision
1975 or something, and then C++ was like 80s or something when it first came out.
And if we have
I don't know how much C++
15
has
digits
changed
in
since
here,
then, though.
The rest is
Probably
going
a
to
lot.
be garbage. Just be aware of that. We're going to try and build this, and we're going to use GCC as usual. And if we run this, we're going to get our numbers in different precisions. The first one is using the default, which is going to be 6. If we use 10, we're going to get 10 digits. If we use 20, we're going to get 20 digits. But if we go over the precision that our type here supports, we're going to get garbage.
So if I did include...
The last thing we're going to see is show point, and we have seen that this is used to force
stdio, not studio.
Outputting the decimal point. Let's say that here. And a good example for that is this 12
stdio,
here. If we print it out
H.
here, we're not going to get the decimal point by default.
I saw the
it's going
C
to
symbol.
print 12. But if we go down and force output of the decimal point, here we're going to get something like 12.0. And another effect of this
I assume
is that
this is what you're referring
it's going to add trailing zeros to fill whatever space is allocated for your output variable in the terminal. Let's try and run this so that we can actually see this running. We're going to run our rooster executable. And in the first group here, we don't have the setting for show point. And if you look at the numbers that we had in our code, the first number is 34.1, and you see that we are padding a lot of numbers because we had set our precision to a really big number in the last example that we have run. Let's actually go there and show you that. That's why we're seeing the precision of 20. It is really huge, but no big deal. We can reset this to whatever we want if this is too much for us. The important thing here is that we have 34.1, and that's what we are seeing. And if you go to our 12 here, so you see we have 12.0, but our output is not showing the decimal point here. If it is important to show the decimal point, we can do std show point here, and it is going to show up. This is really what is important in this piece of code here. And this is really all we set out to do in this lecture. We had a chance to play with a lot of these manipulators.
We printed a bunch of numbers.
The best way to learn about these things is really to try them out in code and try to change a few things and see how that affects the output you get in the terminal. And we had a chance to play with many of these things in this lecture. There is a lot of these guys. I tried to make this lecture as extensive as I can. That's why it turned out to be pretty long. But once you've learned about these things and played with them in code, you're never going to forget them. One last point I want to emphasize again is that the documentation is of utmost importance. It is really good to come here and check things out. For example, if we go to show point here, we are going to get a nice explanation of what this manipulator does, enables or disables the unconditional inclusion of the decimal point character, and you can read all this. And the nice
reading
thing
documentation,
is that if you
from
go
what I
down,
understand,
you're
is
going to
like
have a piece of code that
it's
you can
important
use
to
really
understanding
understand
what the hell it is
they are talking
you're
about.
doing and including in your
this
code.
is priceless if you are
Now
learning.
delete it since they
It
never
is a
mentioned
good
it.
thing to be able to use the documentation. This is really all we set out to do in this lecture. It turned out to be really long, but I really hope it was worth it for you. We're going to stop here in this lecture. In the next one, we're going to learn about numeric limits. Go ahead and finish up here and meet me there. In this lecture, we're going to...
You will forget everything and will always have 4 CPP reference tabs open. I'm just gonna be... I wouldn't be surprised if that's how it ends up going, where I'm just like totally like, oh man, I don't know what I'm doing. Alright, so we got limits, math functions, and weird integral types.
We're going to be playing with a few functions from this library. Specifically, we're going to be looking at the minimum, the maximum, and the lowest functions. And this is really how you use them. You can think of this T as a placeholder for the type for which you want to know the minimum, the maximum, and the lowest point, respectively. I know this might be cryptic to some of you, so we're going to look at a few specific examples. Here we have a simple explanation of what these functions mean for floating point values. The minimum is going to represent the smallest positive number that is representable with that floating point type. The maximum is going to be the maximum floating point number you can represent, and the lowest number is going to be the lowest negative number you can represent with that type. Things change a little bit when you start dealing with integers, and these functions are going to look like this. The minimum is going to be the minimum number you can represent with that integer, and lowest doesn't really mean anything for integral types. The maximum is going to be the maximum number. One thing you have to keep in mind is that the minimum may be negative if you are using a signed integer. If you are using an unsigned integer, for example, for short, minimum is going to be 0 and maximum is going to be the maximum number representable with that integer type. Here we are looking at numbers for short int, but the same story applies to whatever integer type you are using, even if you happen to be using long int or int without any modifier. Remember that we had to do a lot of things to get this range, and it was really hard to even do this for floating point types. So this library is helpful in getting a sense of what we can represent with a given type, be it floating point or integral. Let's head to Visual Studio Code and play with us. Here we are in our working folder. We are going to copy code from our template project. And we are going to go in the current project, which is numeric limits. We're going to go in, put in our files, go up again, and open this file up in Visual Studio Code. We're going to close this up, open the main CPP file, remove whatever it is we don't need. We are going to include the limits library. Remember, this is the first thing we need to do if we want to play with these facilities that we just looked at in the slides. And we are going to go down here and put in the code we want to play with. And it is ridiculously simple.
Holy...
If you have watched the slides we just did.
What the fuck? He says, oh, it's ridiculously simple, as he fucking copies in 34 lines of code. I'm back a bit, hope it goes well. It's been going alright. The last thing that we did was output formatting, which basically makes us able to make tables that look like this. The @ symbol is my own personal touch on the take, or on the matter, but I also, it was a little bit strange to do. I didn't think it was super necessary. This is hopefully a little bit more immediately useful. Let's see. So the range for short is from, and it has the min, the max, and then the oh god. Okay. So std cout. The range for short is from, and then it goes std numeric limits short min, and then I assume std numeric limits short max std end line. Outputting with certain symbols can be annoying at times. It can be. I mean, like, the @ symbols are just stupid. I put them there because you can put anything. Short maxing. Yeah. Like, I think if it was... Where is the value? I think if I changed... Yeah. I changed the set fill. If I had changed this to like a dash or just left it empty even, probably would have been better. Could have just gotten rid of the line, but I'm holding on to this so that I can set fill. Let's see. Fills empty space with the input character. There we go. Yeah. Justifies data to the left. Sets an integer that we use later for column width. All this good shit. I'm kind of hoping that he doesn't have anything else over here. I wonder if you put set fill and it removes all spaces, probably. Maybe. It might. I wouldn't be terribly surprised by that. Wow.
In a minute. So what we're going to be doing here, we're going to be printing out the range for each possible type we want to play with here. So we're going to say the range for short int is from, and we're going to say std numeric limits.
Oh, wait, hold on. There was a little bit more on that line than I thought. Min 2, and then it's this other line. The range for short is from. And all right, this is another one that I think I'm gonna truncate a little bit. I don't think I need to do. I don't really want to do like 6 lines that are essentially the same thing when I can just go in and be like, okay, well, we'll do, we can just do this one for long, one for short, and then maybe one more for, like, I don't know, float. But like copying in 6 lines of text that are functionally no different from each other.
Short, that's what we want to deal with now, and we're going to call the minimum function. This is going to give us the minimum value we can represent with short, and we're going to say std numeric limits, and we're going to call the max function, passing in the type for which we want to get the range for. And the same story applies for unsigned.
Yeah, unsigned is going to be the same quantity,
you see,
but
that's the type we are using
going
here.
only
we are
positive
also going
versus
to play with int, getting the range. We're going to use unsigned int to see how these things behave. We're going to use long and get the range. And we are also going to be playing with floating point types. So we're going to compute the range using the minimum function and the maximum function. And we are going to be also using the lowest function to see that this really is the same thing we described in the slides. We're going to do this for double and long double and see how these ranges come up in this program. What we're going to do is open up a terminal here. We are going to run the test to build with GCC, and the build is going to be good. And we can go down and run rooster, and we're going to get our values here. The range for short int is from minus 32768 up to 32767. And you see that this is exactly the same thing we saw in the lecture where we talked about number systems. We saw a way you can do this manually by plugging the number of digits in some formula that we came up. You can go back and check that out if you want. We do the same for unsigned short int, and then we look at floating point types. We're going to print the range for float, and if we use the minimum function to get the start of the range, we're going to get the minimum
That's a really small
number we can represent with a float. If we use lowest, we're going to get the lowest minimum number, and the maximum is going to be the same. If you think this is really small, you have the option to open up this folder in File Explorer, and you can open a command prompt or a PowerShell window by hitting Shift and right-clicking and choosing this option here, Open PowerShell window here, and you're going to get a bigger window in which you can type things. We're going to run rooster, and we're going to see things in a much easier way here. This is an option you can use, or you can even use the integrated terminal inside Visual Studio Code here, like we've been doing all along. There are a few other facilities you can use in this library of limits. For example, we can try and print out if a number is signed or unsigned, or get the number of digits we can represent in an integer type. These are a few examples I just chose because they are easy to understand and really helpful, but you can find more about this library in the documentation. And if you come here at cppreference.com, the link is here, you can really find all about this library here. This library provides a standardized way to query various properties of arithmetic types. For example, the largest possible value of type int is this. And we have a bunch of things we can do here. Don't be scared off by this template thing. Just think of them as placeholders for the type for which you are trying to query information for. There are a few functions you can call on these things. For example, there is min, lowest, max, that we just played with in Visual Studio Code. But you can see that there are a lot of things you can play with, especially if you have some math background
Epsilon.
to
What the
understand
fuck?
all these concepts here. You can play with this and see if it is helpful for whatever application you are doing. Okay, this is really all we set out to do in this lecture, to learn a little bit about the limits library. It is helpful in trying to understand the ranges for your types. If you happen to need these kinds
it's
of
helpful
things,
to know
this is
that
going to come in handy.
if you want to
We're
store
going
an
to stop here in
integer,
this lecture. In the next one, we're going to learn
or
about
I guess
some
like
math functions
any of them,
we
right?
can use in C++.
If you want to store an integer,
Go
the
ahead
lowest
and
you
finish
could do
up
is
here
like
and
negative
meet me there. In this lecture, we're going to learn about math
214 million or
functions.
some shit.
And these are functions that are built into the C++ standard library that we can use to do some math. If you are doing some math operations, you're going to find these helpful. They live in the C math library, and if you want to use them, you're just going to include that and you're going to have access to them. What you see here is a simple summary of some of the things you can use in these math functions. You can use std_floor to round down or std_ceil to round up. You can use the abs function to compute the absolute value of a number. You can
very
do
good at math. Very good, very good.
The cosine, sine, and
I
things
do actually
like
like
that. You
this.
can compute the
Squirt
exponential of a
incoming.
number. You're going to see what this means in a few lectures. You can use std_log. And again, if you have some math background, these concepts are not going to be foreign to you. Many of these functions are documented
I actually
here
understand.
at CPP reference, so it might be worthwhile to go there and check what functions are available there. Here is an example of something you might want to do. For example, you have a variable
weight rounded to
it's
floor,
called weight,
and then
inside
weight rounded to
7.
ceiling.
7, and
So
if you do
one
std_floor
rounds it down,
of
one
this
rounds it
variable,
up,
this is going
7
to be rounded
or 8.
down to a 7. If you want to round up, you're going to use std_ceil, and you're going to get that. And we're going to see what this is going to give us in a minute when we hit Visual Studio Code. Here is how you would use the absolute value function. You have a few variables here.
Absolute value,
and
that's
if you try
5,000.
to plug them in, this absolute value function, you're basically going to get
I think
the
the
weight
absolute
of
value
the
of the weight
number
would still be
without
7.7.
any sign in front
The
of the
absolute
number,
value of
positive
savings
or
would be
negative.
5,000.
The absolute value is the weight of the number without caring about the sign. If I may say it like that. Okay, we also have the exp function, which is going to compute the exponential of a number. This is a math concept, so if you don't have a background in math, this is going to be a little hard to wrap your brains around. But in math, we have this number which is called e, and its value is approximately 2.71828, like you see here. The exponential function is going to do what fx here is doing. It's going to take e and elevate that to the power of x. And for example, in our code here, we're going to get the exponential of 10, which is going to be e elevated to the power of 10. And we're going to play with this in Visual Studio Code, and you're going to see the value of this. We also have the power function here, which is going to take the first parameter and elevate that
one
to
didn't
the
really
power
make much
of
sense.
the second parameter.
I'm
So
hoping that he'll expand
this is going
on
to
that.
be 3 to the power of 4 and 9 to the power of 3. And we're going to get the answer if we plug this into Visual Studio Code. And we have log functions, which is basically the reverse of the power function that we just looked at. If you do log 8 in base 2, for example, it is like you are asking, to which power should I elevate to so that I get
Go for
8?
it, my man. Get some
and
rest.
The answer here is going to be a 3, of course. But the catch is that the log function by default works in base e. So what we are asking, for example, if we say log 54.59 is to which power should we elevate e to get this number in here? And it is going to be computed, and you're going to see this if you plug this into Visual Studio Code, or you can try to use one of the calculators available to you, and you're going to see that this makes sense. We also have a special function that is going to do the same thing, but in base 10, and this is going to be easier to understand. For example, here we are computing log 10. So what we are really saying is to which power should we elevate 10 to get 10,000? And this is easy because the answer is 4. 10 to the power of 4 is 10,000. I really hope this makes sense. We also have a square root function we can use. So square root of 81 is going to be 9. We have a function called stdround, which can round. And what it's going to do by default, halfway points are going to be rounded away from 0. So if you have a 2.5, it's going to be rounded up to a 3. And if you have 2.4, it's going to be rounded down to a 2. We also have a host of functions we can use in trigonometry.
Oh boy, trigonometry.
We have a sine function, we have a cosine function, we have a tan function. If you know these concepts in math, this is going to come in really handy if you want to do this. I have to say that what we just talked about is a small set of what we can do with these functions here in C Math. And we are here at cppreference.com, and we can see all these functions here. We can do reminder, we can do fmin, and if you want, you can check this out in the documentation. For example, if you go to tan here and click on it, you are going to get the description and explanation of what this function does, and you're going to have a simple example of how you can play with us. Okay, now I hope you have a better idea of what we can do with these functions in the CMath library. We're going to head to Visual Studio Code and play with some of these functions.
All right.
Here we are in Visual Studio Code. The current project we're going to work on is math functions. We're going to copy over our template files, and we're going to put them in our directory here, math functions. And we are going to open this up in Visual Studio Code, and we are going to remove whatever it is we don't need. And we are going to include our library, which is CMath. And we are going to put in our code so that we can play with us. And here we have a variable called weight. Okay. And we're going to try and use a few math functions on it. So we can use stdfloor to round down and stdceil to round up. So weighted rounded to floor is going to be printed out, and weight rounded to ceil is going to be printed out. We're going to have a number here. In this savings variable, it's going to be a negative number. And we're going to try and compute the absolute value of this. We're going to see it printed out. Another thing we're going to compute is the exponential of the value.
Hold on. I gotta get some of this stuff in here. STD and line. So I get this. So this one is for the floor. This one is for the ceiling. Weight rounded to ceiling. STD ceiling. Oh god. Oh, it's just ceil.
We're going to do stdexp10, and what this is going to do is going to take e and raise it to the power of 10, and that's what we're going to get printed here. The other thing we want to do here is compute the power of a number. We're going to take 3 and raise it to the power of 4, and take 9 and raise it to the power of 3, and we're going to see what these things evaluate to. We're going to open up our terminal here, and we're going to run the task to build with GCC. The build is going to be good, and if we run Rooster, we're going to get these things here. So 7.7 rounded to...
Hold on. I'm going to get my stuff in here. So we got one for weight, one for savings. So savings. So floor should immediately just round to 7. So the goal, so what I see, should be 7. Ceiling, it should round to 8. Absolute value of weight should be 7.7 is my guess. I'm not 100% on that. I assume that it uses the same type since it's a double, so it should still have the decimal in it. And then the absolute value of savings is 5,000 because all absolute does, at least in my mind, is just get rid of it gets rid of any positive or negative sign. It's just this is the weight of it one way or the other. Which weight is probably not the best thing for me to be saying, but you understand hopefully what I mean.
Floor is going to be 7, so we're going to round down. 7.7 rounded to seal is going to be 8, and that's what we're going to get. And the absolute value of weight is going to be 7.7 because it is a positive number, and the absolute value of minus 5,000 is going to be 5,000. And again, when you compute the absolute value of something, you are interested in the weight of that thing without considering the sign, without really worrying if it is positive or negative. You just want to get the magnitude of a number. That's what we use in math to mean that. Magnitude. Okay, so if we go down, we're going to get the exponential of 10 is exponential. And
right. Let's add these lines. Double exponential equals std exp 10 std cout the exponential of 10 is and then we have our exponential std and line. I'm curious what that's going to spit out, because it seems, I was kind of confused by what he said with like not being, like he mentioned some point during the lecture where it was like 2 point something, and like the value of E was some amount that I don't recall. And I was a little bit unsure of what he meant by that, because I was kind of under the impression that E was just kind of a stand-in for times 10 to the whatever. Like, at least in scientific notation. And it kind of had me a little bit messed up. 9 to the third is, and it should be std how 9 3 std end line. So 3 to the fourth, that's 81. 9 to the third is I need to comment that. And then 9 to the third is, what's 81 times 3? 729, I think. Because it's 80 times 9 is 720. Yeah, and then another 9 on top of that.
You're going to get that here. And again, what this function does is take E and raise it to the power of 10, and that's the answer here. We can try and prove this with a calculator. So I am going to open my Windows calculator. You can use
I'll be interested in seeing this, because what the hell is E?
Access to. I am going to use a scientific calculator here, and you see that we can
Is it
hit
Euler's
E,
variable?
and we're going to get the value
Is that
of
what
this
is that what that E is supposed to mean? Is Euler's fucking thing?
E number in math. Here it is simplified, but
It's like an
if I
irrational
take
number.
it and raise it to the power of 10, the answer is going to be 22.026. And if we look in our program, we have 22.026.5. Okay, it is rounded up a little bit, but
Okay, so then we'll task. Let me add it with clear. So we have weight rounded to floor, yes. Weight rounded to ceiling, yes. Absolute value of weight, yes. Absolute value of savings, yes. Exponential value of 10 is 22.026.5. It is rounded up a little bit. And 3 to the 4th is 81. 9 to the 3rd is 729. Okay.
it is almost the same thing. Okay, we also want to play with log functions a little bit. Log is basically the reverse of the power function.
It's the reverse.
And we just talked about this in the slides.
The negative to
if we do log 8 in base 2, we are basically asking to which power should we raise 2 to get an 8? And the answer to that is going to be what this log number in base number is going to be.
Logarithm is one of those things that's hard to like explain.
The log function, if you use it row like this, it is going to be using base E. And we just saw that E is 2 to the power of 7 or something. Let's go back to our calculator and see if we can see that. Why not? Why try to guess when we have a good calculator in our hands? We are using the scientific calculator. So if we hit E here, this is the value of E. Okay, so when we do log, we are basically asking to which power should we raise E so that we can get this 54.59. And the answer is going to be computed and printed out here. We have a version of this that is going to use base 10. So if we use this, we are basically saying to which power should we raise 10 to get 10,000, and the answer is going to be printed out here, and it is going to be a 4 because this is easy to do in your mind. So let's run this. We're going to build the task. We are going to run the
so then the second one that he does here is std cout to get 10 or to get 1,000. You'd need to elevate 10 to the power of, then he goes to here, and it's std log. He has two different numbers there. I think he's doing 10,000 in both. 10 to the power of, and this one should be, that should be the 4. I have mine on the wrong one. And yeah, so this should be 4. Yeah, so if you do logarithm by itself, it's very, I think it's difficult to kind of do like on paper. It's not something that I ever learned on paper. I know how to do it on calculators and the value of it and what the graphs look like.
And we're going to run our program, and we're going to get our output here. To get 54.59, you would elevate e to the power of this number here. This is the answer. And if you want to prove this with your favorite calculator, you're going to get something close to this. To get 10,000, you'd need to elevate 10 to the power of 4. That's what we're going to get in here. Let's print this out. Again, many mistakes. Sorry, but I hope you get the point. If we build again so that we can see things properly and run, we're going to get proper data. And this is really what we expected to get. We have a few more functions we can play with as we saw in our slides. let's play with square root and the std round function.
Square
Here we
root,
are
I
going to
mean,
get the square
we're kind
root
of doing
of
the same thing that we
81. We're
did
going
with
to get it printed out, and we're going to see
when
what
we were
std
doing
round
addition,
does.
right?
It is going to round away from 0 if we are at half point, and if we are not at half point, if we are below that, we're going to round down. If we are higher than that, we're going to round up. We're going to run this so that you can see this running, and we're going to call rooster, and 2.5 is rounded to 3, 2.4 is rounded to 2, 3.6 is rounded to 4. This is what we expect, and the square root of 81 is 9. This is really all we set out to do in this lecture, to play with a few of these CMath functions. They are not really hard to use once you have the basics of math nailed down. And again,
when you know how to
if
do
you want
basic
to
math,
check the full list
you can
of
do
these functions, please come to our reference documentation here. You're going to find a lot of them. And if you want to see how to use one of these, for example, if you click on log 10 here, you're going to come here, you're going to get an explanation of the function, and even better, you're going to go down and get a nice piece of code you can play with and really make sense of what is happening in these functions here. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about some weird integral types. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about some weird integral types. And what do I mean by this? Well, if you look here, integral types less than 4 bytes in size don't support arithmetic operations. And these are operations like addition, subtraction, multiplication, division. You can do these operations on those types. And here I have an example of some of those types. We have a car. It is 1 byte in size, and short int is 2 bytes in size on most processors. So you can't do arithmetic operations if your integer value is stored in these types. Why is that? Well, this has to do with processor design, and they decided to choose int as the smallest type, integral type, for which they can do these arithmetic operations. But compilers are really smart enough to notice if you are trying to do arithmetic operations on these types, and they are going to implicitly convert from these smaller types to int. And this is something you need to be aware of. If we look at this program here, for example, we have var1 and var2. They are stored in variables that are of type short int. And we have var3, var4, which are stored in a variable of type char. We can try and print the resizes, and we're going to get 2, 2, 1, 1 for these variables because a short int occupies 2 bytes in memory for my computer here, and the char occupies 1 byte in memory. But the catch is down here. If you try to add them up, the result is not going to be the same type as the things you added up, and you would expect auto to deduce to the same type as var1 and var2, and it's not. Result is going to be an integer because int is the smallest type for which we can support these arithmetic operations. So if we print size of result 1 and result 2, we're going to get 4, but this is the behavior you're going to get, and we need to be aware of it. The same behavior can be observed on other operators that we will have a chance to look at in a few chapters ahead. And these are called shift operators. You use them to shift bits, but I don't want to talk any more about them because we're going to have a chance to learn about them in detail. Okay, now it's time to head to Visual Studio Code and actually see this in action. Here we are in our working directory.
Should be doing this.
We are going to copy our template project.
This is
going to copy this.
I think the last part
Quickly
of chapter
put that
4.
in our folder on weird
This is going to be kind of strange.
types. This is our current project here, and we're going to open this up in Visual Studio Code. We're going to open this up, and we're going to open our main CPP file, remove whatever it is we don't need, and we are going to put in our code. This must be very familiar because it is what we just saw on the slides. So what we are doing here, we have 4 variables. var1 and var2 are short int, so these are going to take 2 bytes in memory on my computer here, and char is going to take up 1 byte. And we're going to print their sizes. We're going to see them printed out. And we are adding things up here. We are taking two short int variables and adding them up. So what the compiler is going to do, it's going to take this, turn it into an int, and then do addition, and the result is going to be an int. The same story is going to happen for result2 here. var3 is a car, so it is 1 byte in memory, but the compiler can't really add up integral types which are smaller than 4 bytes in memory. So what is going to happen? var3 is going to be transformed implicitly behind the scenes to an int, and var4 is going to be transformed to an int, and then we're going to add that up, and we're going to store that in an int variable, which is result here. If we print this up, we're going to see that size of result1 and result2 is 4, and this is what we expect here. And this is a behavior you need to be aware of, because sometimes your application logic is going to depend on the size of data. If that's the case, you need to care about this. And if you don't know this, you're going to be bitten by this. And it is really hard to find problems like this. So what we can do is open up our terminal. And we're going to build this with GCC as we usually do. And we can run our program rooster. And we're going to see that this is what we expect. var1 is 2 bytes in size. var2 is 2 bytes in size. var3 and var4 are 1 byte in size. But our result is 4 bytes because the compiler implicitly converted our operands here to ints to be able to carry out this arithmetic operation. This is really all we set out to do in this lecture.
Okay.
I hope you found it interesting.
That's
we are
interesting.
going to stop here in this
So
lecture.
it doesn't actually change.
The next one we're going to try and recap what we saw in the chapter.
Okay. So wait a second. Oh, okay. So this is the summary section. I'm sure he said it already, but so when we look at this, right, we see our how many bytes are each of these is taking up, right? And so variable 1 and 2 are both taking up 2. The characters that we're storing, variables 3 and 4, are both, it's 2 and 1. So it doesn't affect the size of these things because these are, we haven't told it to change that at all. But before it can actually spit out our results because we wanted to do math with them, it did have to convert them into I guess integers, both of them, and now result is automatically an integer. Interesting.
Congratulations on hitting the end of this chapter. And this chapter was really about doing operations.
This chapter was a lot of
manipulating
math.
The data that you have stored in your variables. The first thing we saw was that we could do arithmetic operations on the data. We can add things up, multiply, divide. We also saw the modulus operator, which may seem weird for beginners, but we had a chance to really play with us. After that, we learned about precedence and associativity. We saw that that's a set of rules we have to follow to know which operation to do first if we have multiple operators in our expression. We also had a chance to learn about prefix and postfix increment and decrement operators. We had a chance to do compound assignments, things like plus equal, minus equal, multiply equal, modulus equal. Now these things must be making sense to you. We had a chance to look at how we could compare things using relational operators like greater than, lesser than, and equal or not equal. We also had a chance to look at output formatting, and we saw a host of things we could do to make data show up better with stdc out. After that, we learned about numeric limits, and this is a cool way to know the ranges for your data types, but there are a host of other properties you can use in this limits library. We learned a little bit about math functions, and we played with things like the power of something, the exponential, the few rounding functions that we have in the CMath library. And now you must have a good idea about these functions that you can use to manipulate and do math on your variables. We ended the chapter by looking at some weird integral types, and the main message in that lecture was that you can't do arithmetic operations on data types whose size is less than 4 bytes in memory. If you try to do that, the compiler is going to insert implicit conversions, and if your application depends on the size of things, this is something you need to be careful about. Otherwise, you're going to have a hard time finding these problems. I would like to welcome you in this new...
Okay, so that's flow control. I think that gets us to chapter 5. All right. So, I think that's enough for the day. We've been at it for wow, almost 3 hours. Holy shit. Okay. I think what I'm gonna do is I'm gonna go ahead and save all my stuff. We're gonna close this down, and we're gonna go over to here. Wow. What I mean, what a journey. So that last chapter, that last entire thing has been math. Like we've been doing a lot of different things with mathematics, which is fine. I'm good. I'm fine with math mostly. I'm not like I don't have like an extremely good understanding of most math, but it is I have a decent enough understanding to be able to understand fairly quickly what he's talking about in the video. You know, things like floor and ceiling, and the thing that had me a little bit confused is that E is Euler's variable, or not variable. Is it variable? I think it is. At least that's what I think it's called. Let me double check before I make a fool out of myself. Euler's variable. Or is it formula? Where E is the base of the natural logarithm. Natural logarithm. Yeah, and that's the 2.71828. It's approximately equal to. Yeah, there's a whole lot of math on this shit. But anyway, so that was the only thing that kind of confused me a little bit, because I didn't know that off rip. But it is interesting to know that computers use that like implicitly as well. I think I've only ever had to do like logarithm in like base 10, or like a log like base 2 or something. Never calculating a natural logarithm on paper was never something I ever had to consider before. But yeah, so next is going to be flow control. I'm not exactly sure what that implies, what that entails. I'm kind of hoping it's a shorter chapter. Let me look at it real quick. I have to open the thing again. And he's going to try and talk, but he's an experienced software developer. I know. So flow control. So there's an introduction. If statements, else if, switch, ternary operators. I don't know what that is. We might be able to get through chapter 5 in one stream. It's only an hour long compared to chapter 4 was 2 hours and 15 minutes. And I streamed this last one, the second half of this, for like 3 hours, so yeah. We might be able to do it depending on how quickly he moves, how much of it I can kind of understand or intuit, one way or the other. It'll be interesting to see for sure. Anyways, so with that, I think I'm gonna get some dinner. I hope you guys had a good time hanging out with me today. I'm gonna be going live later tonight with some more Duke Nukem gotta do both. I appreciate all of the support that the C++ stuff has been getting. It's been encouraging to see, and it's very it feels good to get a positive response on all that. So we'll be back later tonight at around 11 p.m. So in about 5 hours with Duke Nukem. and we'll continue C++ tomorrow at around the same time. I've been doing it a little bit first it was like 5, and now it's at 4. Today was at 3. I'm going to try and keep it to around 3, but I'm not 100%. It's going to be sometime in the afternoon is when I'm going to be doing this stuff. If anybody... I mean, if anybody is doing this along with me, I mean, fucking, it's a lot of it's interesting. I think fun is a very subjective thing. I think it's fun, but it's certainly very interesting. There's a lot of cool things to learn, and who knows? Maybe I'm curious how the tests for C++ look. So we'll hopefully see those in a few weeks. Anyways, I hope you guys have a good one. I will talk to you later, and shit, man. See you then. Bye.